Alright, so does everyone see my screen here? I'm on Twitch. Yeah, sorry. Yep. Everyone on yet? Cool. Alright. Alex, are you here? I haven't heard from you at all. Just wanted to check. Might be muted. Go ahead and shoot me a message if you're present. Yeah. Okay, so yeah. Um mhm. Yeah. So you can't exit this sketch once you get your little semicircle fully defined? Okay. Let's try a couple of things. So you have this centered here, right? Um, you've got this line like kind of centered with your origin. I've got it sideways, but I'm trying to. It's like oriented funny, so when I drag it, it goes the opposite way. Um, so what if we add a relation? I'm just gonna try and get it fully defined here real quick and just see what happens. I might have the same problem you did, but so if I make that horizontal there, okay, that didn't really help get it defined. Um, okay, so one thing is when you like grab things and drag them around, you can see by how they're moving, you can tell what's not defined. So you know that, like for instance, the length of this line isn't defined. So let's undo so it's the size you wanted it. But then let's give that line a dimension. And it's 5. So that's probably, I'm not sure if that's what you were trying to do, but see if that does anything. It's still underdefined, so alright. So now it's not, it won't stay in the center. So let's see. So I just gave it a horizontal relation, but one thing we can do, let's try doing this. Let's just make these two lines into lines in this sketch so then we can do this. And we'll say there, shoot, well, let's not do that. All right. Yeah, so I went into edit sketch 5 here. Alright, I still got these 2 lines. I'm going to try and delete those. So I'm just kind of playing around with this. Obviously, I haven't really made any progress either, but um hmm, let's try something else. So see how the center of this line isn't right on this circle here? Let's try putting a relation there. Ah, okay. Yeah. Yeah, because I just added the relation and nothing changed, so I'm sure. Yeah. Oh, yeah. Probably because like this circle is actually kind of a giant polygon in SolidWorks because it's not like, yeah, it's a little bit like pixelated or something. I'm not sure what you would call that, but yeah, exactly. Let's try dimensioning this. I think the thing that we really need to do here is we just need to get this to stay centered. And I'm having a hard time figuring out how to make it do that because I can't seem to like, let's see if I can like select a point here somewhere. There we go. I just got it. Okay. So what I did was I made, this is a little bit silly, but I made this line the midpoint of this line. So the midpoint of this line is like somewhere in here. I was able to hover my mouse on it. And I just added a relation where this point and this line, well, this line is at the midpoint. So, yeah. Alright, so let's see if we can exit sketch now and if it'll be fine. It looks like it's alright. The circle is like funny and lumpy looking there. It's kind of weird. It's yeah, the way you've got this oriented, it like moves backwards to the way I move my mouse. It's confusing. Um, but yeah, there you go. Mhm. Yeah. So I think the problem you were running into is just that when you like when you make a new sketch on a part, um you always have to define that sketch in relation to the rest of the part. Um And so that was what was missing, was pretty much just a couple of definitions in relation to the rest of this part. Um, and once you have those, it'll never be fully defined if like your new sketch is just floating in there somewhere. Does that make sense? So your new sketch might be fully defined within itself, but it's not fully defined. Um, yeah, yeah, exactly. It's still floating out in space somewhere, even if the sketch itself is defined. So, all right. Any other questions about that, or? Uh, so yeah. Mhm. Okay. So you're asking how to draw that shape, or how to print it? Okay. So you want it like not extruded in a straight line. So you're like extruding something and you want it to come out. Okay. Yeah. Mhm. Yeah. So there's a few things you can do, and let's see if I can actually just do this on the fly. I might have some trouble here because it's kind of one of those things you got to think about. But um, all right. So say I want to make a propeller, but I want to start with like a cross section. So they're usually sort of elliptical, right? Um, so that's like the cross section of a propeller, and it's gonna come to a point on either end and kind of twist a little bit along the length of it. So let's just give it a dimension here. I don't know. Oops. I don't know. I'm just kind of making random stuff here, so bear with me. Um, no, I don't really remember how to fully define an ellipse either. Yeah. Yeah. Let's see. I think I can get it almost there with just a couple more things. Okay, so we just gotta define the length of it. So, the thing with ellipses, they always have these points on them, so you can um, pretty simply get it defined using those. The other thing is relations are important. So let's make this horizontal. Let's make these two vertical to each other. That might do it. Oh, shoot. There we go. Okay. It's getting there. I'm not going to worry about that too much because that's not really the point of this, but okay. Let's just exit sketch. Alright, so then, one thing you can do, let's see, let's do a, let's try this. So the thing that is tricky is you're trying to kind of do something in multiple dimensions all at once. Um, so like I have a two-dimensional thing here, and I can extrude it either way, but it's still going to be the same along its length unless I have some other reference in that third dimension to define what it's doing in the third dimension. If you just, if you just extrude it, then the third dimension is going to be, it's going to be the same ellipse the whole way along. So we're going to end up with like, let's do 10. And that looks like kind of a long propeller blade there. You can do a couple of things, like you can taper it. Let's do like, that's a pretty crazy taper right there. Could switch the direction, and I think that's, oh. Let's try doing like 10. Still a pretty crazy taper. But you end up with like this ellipse that's a totally different shape from the one that you started with because it kind of expands equally in every direction. So you don't really want that either. So let's not just do a regular extrude. So we can add in reference geometry. Let's see, are we in sketch 1? Okay. So let's do an axis. Let's like start. Okay. Come on. That axis is going to be on the same plane as our existing sketch. So, yeah, I'm having trouble really coming up with an easy way to do this on the fly. But one thing, I guess that in principle, what you would do is like, remember last week when we did threads, we did a curved line, and then we made the threads on that. So it would be a similar concept. I guess you would probably, let's delete this axis. Yeah. Here, let's try extruding this actually. Okay. In the meantime, I think I have an idea of how I'm going to go about this. So we extrude that. Yeah. So let's try doing like a curve here. Let's not do that kind of curve because I don't really have reference points. Yeah, we were talking about like a propeller or something. So we're talking about like how to make something extruded but curved, like the way a propeller would be kind of curved. Um, like it's not just a flat thing. It would like taper at the ends and it would kind of twist a little. Yeah. So I'm just kind of Oh shoot. All right. Yeah. Okay. Yeah. I'm not really. Let's go back to that. I'm gonna think about this curve thing because there's ways to do it. Like if I were to have to do this for something, I would probably play around with it for 2 hours, and then. But what were you gonna say? Oh, cool. All right. Yeah. Here, I'm gonna. What was that? Okay. Perfect. Cool. All right. I don't know if. Okay. Cool. All right. I'll pause this for now. That makes sense. Huh. All right. Okay. That was kind of this one here. Because I know to use that you do need like you need a contour to sweep it along because that was what we used to yeah, that was what we used to make the threads. And so you just need that line, that starting line to sweep. Hmm. Okay. Hmm. Okay. So here, let's try this. I'll sketch on the right plane. I'm just gonna make like I'll do a center line here. It's a lot of fun, huh? Cool. All right. Yeah. SolidWorks, usually the new versions don't change very much. Like they might add features, but they don't ever really change how you do things too drastically. So typically if you find like old stuff, you can still use it. You might run into situations where you're like this doesn't look the same, but usually it works. So, yeah, go for it. I don't know if you can do it in the group though. I think darn. Yeah, I think there's permissions on there or something. Unfortunately. I wonder if I can change that. I think I'm looking for it. Uh, all right. Okay. I think I just changed it. See if you can share your screen now. No? Shoot. Okay. I'm gonna try again. Edit channel, permissions. Alright, try now. There we go. Nice. Alright, cool. Can everyone see it? You should, if... Oh, the stream just ended, so... I don't... Oh. It's alright. I've got it back. So that's your gear with the interchangeable teeth? That's pretty cool. So that's kind of a neat idea, because if you want to test several different types of gears, you can print different teeth and kind of try them out. I don't think it's necessarily going to save you any material in the end, but yeah. Yeah, you can just reprint that one piece. It's pretty neat. I like it. No, you're doing great. Um, yeah, I always like seeing what everybody comes up with. My favorite projects to assign are always like the really open-ended ones where it's like make whatever you want, because you guys probably kind of hate it 'cause you have to come up with something, but um, it's a lot of fun to see the stuff people think up. So, hmm. Uh, oh, bummer. Uh, yeah, that's super annoying when stuff like that happens. It's kind of one of those things with SolidWorks too, because it's such a like it's one of those programs that uses up so much space, that I mean, it crashes your computer, it like will do all kinds of annoying things. Um, so yeah, cool. So I actually wanted to talk a little bit about ways to make gears today. I know we were kind of still working on some other stuff, but I wanted to oh, okay. All right. All right. Yeah, I mean we can if we have time we can definitely go over it again. But let's try and do this sweep thing here real quick first. It gave me an error that time, so let's see if I can. So the sketch profile is going to be this one. Oops, that's not. Hmm. No. Let's try this. Huh. All right. Yeah. So when I did this before for the threads, I had the profile is going to be your sketch, and then the path is going to be the line that it sweeps along. I think because this is just a center line, it's not an actual line, maybe. So let's try going back into that sketch and let's just do a real line. Let's actually try starting it at this point here. I guess I didn't actually start it at that point. Let's just put it on the origin. Maybe easier. Okay. So for our profile, we're going to do, let's just go in here. We'll do sketch 1, and the path will be sketch 2. So there we go. And because the path is straight, it's not really going to curve at all. But if you wanted to make it curve, you could give it a twist of like, let's say 10 degrees. Ooh, wow. That's 100. So it twists just a little bit. And then you could also taper it. So, and I didn't make this very long, but we can change that. Yeah, it's fun, huh? Um, so yeah, so you just want to go into options and then profile orientation is going to be follow path. Profile twist, you're going to specify twist value and you're going to do it in, you can do it in degrees, radians, or revolutions. So if you did revolutions, it would be like a decimal because it obviously revolves less than once. So if you did one full revolution, it gets really twisty. Because it twists 360 degrees, you can see, but let's do degrees. Yeah, let's do 30. There we go. It's kind of cool. And then let's see if we can taper it. I'm not sure how to do that, but all right. Let's just start there. And let's make it longer. So what we can do is we can go in Sketch 2 and edit, and we can give this line a dimension. We can just, instead of 0.61, let's make it like 5. And exit sketch. So now we've got like a long kind of curved shape here. So true. Yeah, or we could do like a chamfer. We could also try this. I'm not really sure how this works. So I don't know if that did anything. Oh, I have failing features. Oh no. Alright. Let's try doing this. Let's try doing. Yeah. Yeah. A lot of the time, yeah, sometimes in the, like in the interest of time, you just need to kind of simplify what you're doing, but I mean, the thing that's really cool too with SolidWorks is like you're always given enough time, there's always a way to do everything. It's just that some stuff is really complicated and it's kind of a pain and maybe you have no idea how to do it or even how to like ask how to do it. So, um yeah, I mean that's kind of the point of this though, is like let's play around and let's kind of bounce ideas off of each other and figure out ways to do all this cool stuff. Like I just kind of figured this out. I mean with your help, with help from you guys. So like it's definitely yeah, you can always learn new stuff and it's just a lot of like throwing ideas around really is what it comes down to. So I'm still trying to figure out how to taper the ends here though, so it really looks like a propeller. Like I want it to kind of come to points. Yeah. Yeah, so you would actually here, this is how we can do it. Because we're extruding from sketch 1 out, right? So if we made sketch 1 like the center instead, let's try this. Yeah, I'm recording on Twitch, so yeah. I just had to double check. I was like, I did record that, right? Um, let's see. So sketch 2, if we edit sketch 2 and then we make this line uh let's delete that. And then let's add a different relation. Let's make this line and the origin. I think I selected the end point of the line, though. That's the problem. Let's get out of there. Okay. So we'll do origin and line 2, and let's make it midpoint. Alright. And then exit sketch. Now our I don't know if that actually changed anything. Yeah, it did. Okay. Alright, but now we need to go back and edit our feature here. Sketch 1, sketch 2, and let's do that. Let's do midpoint here. So the thing is now it's going to twist funny. Yeah. Yeah, it is. It's you need two separate sketches because you need one for your profile and one for your path. So I'm just trying to get my twist to like go on both sides though. Oh, I guess direction 2 would be yeah, so I did let's see. Kind of. Yeah. Yeah, so I'm trying to get it to oh, you know what I need to do. So we do 30 degrees on both, but one of them we flip. There we go. So you just click this little symbol here to flip the other one. Yeah. So, and then yeah. Yeah. And then the other thing is I still want to try and taper the ends. But I feel like that should be in the options. It's just not. I feel like we might have to go about this a whole different way if we actually want to taper it. Because when you extrude something, like you just do a straight extrude, you can taper stuff. You can taper it in either direction, and you can taper it as much as you want to where it like even just comes to a point. But with the swept one, I don't see that option in there. I feel like maybe I'm like just not seeing it. I keep going back and like looking for it, but I don't think it exists for this. Um, oh, that's kind of cool. You get a preview of the shape, so it kind of projects lines on there for you. And you can make it denser or less dense. Give it stripes, like it's super shiny. Ooh, that's crazy. Curvature combs. So I think these like are just like every line of the curve extends out past the edge of the part. I'm not really sure if that's true, but that's what it looks like to me. It's pretty neat. Alright, so that's probably a good start. If anybody comes up with a way to taper it and make it look like a more like a propeller than it already does, that'd be super cool. And I'd love to know. But for right now, let's go on to gears. I just wanted to cover that real quick. There's not a whole lot to it that I need to go over. I just wanted to kind of show you guys the basic idea real quick. Um, so, I'm sorry, I keep drinking water and my water bottle whistles every time I drink out of it. Um, so let's just go ahead and close this. I'm going to save it because it's cool. Let's call it. Alright. So let's just do a new part. And, so the first thing I want to show you is in the toolboxes, and some of you already know about this, but if you go into your menu over here, this one that looks like a little stack of books, the design library, so click on that and go into your toolboxes. And if you've never used this before, it's going to say it's not installed or not connected or something like that. So yeah, so just click add in now, and it should all show up here for you. You should already have it on your computer if you have SolidWorks. It's just if you've never used it before, then it asks you first to add it. So you can pick any kind of units of measurement you want. I mean, obviously the ones that we all know are probably inch and metric. So I'll just go with inch. So double click that folder. And then you have these options for different things that you can get out of your toolbox. And there are just like commonly used mechanical components. So you can do bearings, bolts, and screws. That might come in handy if you don't feel like creating threads. But you want to bolt. And you have all different types of heads on them. So, and then, let's see. In bearings, you've got ball bearings and roller bearings. So there's all these guys. Let's just go back. And bushings. Yeah. Yeah, so basically you can take anything out of here and you just put it in here. And you can say make a derived part or no, I'm not sure what the difference is, but do you want to use so this has different units of measurement than what I have open right now. You can see down here I've got MKS, which is metric, and I chose the inch option out of my library. So it's going to ask me this question. I could change the units of the derived part, which is my part right here, to the units of the base part, which is what I'm working in. Or no, I can just keep this in English units, even though I've got metric here. I'm going to click yes. So, and there's a little bushing. You can look at the, let's see. Where am I? the material isn't specified here. So I guess I kind of thought they might specify stuff. I think they do for some things, but um, bushings can be made out of any material. So I guess they wouldn't specify those. A lot of the time they're like plastics, like Teflon um, or like a soft metal if it's um, I don't know. It just depends on what you're doing. But let's delete that because that's not what we're actually trying to do. Someone's phone is ringing behind me and it's really distracting. Okay, so let's go back into our library here. So those are bushings. We've got keys. So like a key that you would put in a motor shaft if you're going to put a pulley on there. Nuts. So obvious what those are. O-rings, pins, like dowel pins, also pretty obvious. Power transmission is going to be where your gears and pulleys and stuff are. Got retaining rings. I hate working with retaining rings, by the way. There's like special pliers for them. Some of you probably know. They're super annoying because they go flying off the pliers and hit you in the face. And yeah. They're so annoying. So structural stuff. I think these are like pieces of like rebar, pieces of beam or angle iron kind of stuff. Pipes. And you've got aluminum ones and steel ones. So there's an example of where they might specify the material. Let's try this. And no, they didn't specify the material. That's interesting. I guess they probably don't then. Oops. Yeah, okay. So yeah, let's go into the power transmission here. So let's start with gears. Let's do a spur gear because that's kind of the simplest one. We'll drag it over here. Just drop it in. Yes. And then over here on the right, you can edit the feature. And, oh, this looks different. Dang. Okay, I was working on this yesterday at home, and there's like a whole menu over here where you can totally configure it. Darn. So, shoot. All right. This isn't going how I wanted it to go. I had it all like set up yesterday and there were all these options over on the side here and now it's not showing up for me. Oops. Let's try doing this again. I might have just skipped that step. All right. Oh, here we go. So you got to right click and click configure. That's what I missed. Maybe. Yeah. Maybe it's create part. That's what it was. It was create part, not configure. Okay, so you're going to get like this gear in here. It's just going to look like this. But over here, this is where you can configure everything. So you can give it a part number. which you would just type in whatever you want here. You can use this one that they assign automatically. You can go back and edit it, and you can just call it, I'll call it spur gear 1. So the pitch, I'm not sure what I'm changing with that actually. So let's just leave that at 1. So you can change the number of teeth, which is pretty helpful. So we were talking about ratios and how to handle that stuff. So like if you have a gear with 10 teeth and then you have a gear with 5 teeth, one of them is going to spin, the one with 5 teeth is going to spin twice as fast as the one with 10 teeth. So the smaller your gear, the fewer teeth it has, the faster it's going to move in relation to another one. And the ratio is always like just a fraction. So like 20 to 10, you can reduce that to 2 to 1. So you've got 20 teeth and 10 teeth, you've got a 2 to 1 ratio, right? So it's not too complicated. It's just a little bit of basic arithmetic, which can be annoying. But say you have like 15 teeth on one gear and you have 5 on the other gear, that would be 3 to 1. So the little gear is going to turn 3 times every time the big gear turns once. What's that? Yeah, you shouldn't generally have more than a 3 to 1 ratio between gears. And I can't really remember the principles around that, but I know like there are occasionally bigger ratios. I don't really remember the actual mechanical principles there. That's going to be kind of another conversation for another day, but um let's call this one, let's give it 20 teeth just to be crazy. And then pressure angle, you've got 2 choices here. It's basically just the angle of the edges of your teeth. So obviously these made up with other teeth, and if you have a bigger pressure angle, that means your teeth come to more of a point. So they're gonna mate with, I guess, if you have a bigger, I think it's like if you have a bigger ratio of gears to each other, then you need a bigger pressure angle. The face width, let's do like 5. That just makes your gear thicker. You probably want a relatively wide face width if, like the bigger you make your gears, but you also want them to be the same, right? So like if I have this gear and then I add in another gear with like, and it's way smaller, you kind of want it to be a similar width so that they match up nicely. Hub style, not really sure what that, oh, I see. It's so if you want like a hub on your gear, so if instead of a shaft going through your gear, it's actually fitting into something, I guess. You can do that on one side. So the diameter you can change, so let's make it like 5. Change it on both sides. The overall length, so you can make your hub a little longer or shorter. Let's make it 3. Did that actually do it? It's thinking. Oops. And I think I just actually exited because I hit enter twice. Shoot. Oh, really? Here, let's try this again because I just messed up. Okay, now we're back. So basically you can make these properties all kinds of different things. So, I just made my pitch like way different. So, basically, this is going to be your diameter, right? I think. Um, Diametral pitch, but the bigger I make it, the smaller the gear actually gets. So. Yeah, if you like exit out of this here, I think it like saves it for you somewhere. Uh, hmm. Yeah, it's gonna save it here. So if you just copy this location, then when you hit enter, you're gonna have an empty screen here. Hmm. So then go back in your design library. The way I got mine to come back was I just went back to Spur Gear, right click, and I just made a new one, and it brought back what I like all the parameters I had just set up. So, but copy and copy this file location because that's where it's gonna save it to. And that way, once you've saved it, you can go into your folder here. Did it go there? I don't know. It might not be doing it because I've already got this open. So. All right, let's do one thing at a time here, though. So, you can change your shaft diameter, which right now it's 1/32. Let's make it like 1/16. Still nothing. You should have like a hole in the middle of your gear here. I wonder if it's just too small to see. Oh, yeah, I think it was just too small to see or something. So that's just 6 inches, which is kind of huge. Let's go to like 3. Okay, that was weird. Why did it do that? It's acting really funny here. I guess maybe it's got to be bigger than the... Maybe it's because I did a hub. If I do no hub, and then... Because I think that replaces the shaft. Okay, yeah. So if you get rid of your hub, then you can do it. You can do a hole for a shaft to go through instead. And you can change the size here. If you want a keyway, you can do that. So you got a little keyway slot there. Or you can do 2 keyways. You do rectangular keyway, or you can do 2 of them. I'm not sure what this show teeth thing is. It puts the number of teeth at. Oh, I see. So it'll hide all the ones except for what you're showing, I guess. If you don't want to actually have them all on there. So that's 15 of my 20. Let's just show all 20 of them. Okay, and then this is your file name right here. And you can change that if you want to. So. Alright. Let's give it a part number. Let's just call it that. Let's copy this. Let's click OK. Alright, and it disappears. So maybe if we go in here. Ah, okay. So then it'll save it here in our folder. That's a helical gear. That's something else. Um, okay, so this is our gear. So anyway, so basically you can take that gear and you can add it into any assembly you want now. And you can save it somewhere else if you want to. So it's not in that folder where it automatically saves it. Um, but yeah, that's the most simple way to make gears on your own. Um, and there's a bunch of different options. You can do this. So you have like a rack which your gear sits on. Let's actually make this reasonable though. Um, let's do 20. Huh. Okay, so obviously these are really big teeth because only 3 of them fit on a length of 20 here. But the longer you make it and the smaller you make your teeth, the more you'll have showing up. So, alright. So there's that. And that's pretty much how you do that. You can do all kinds of different ones and choose whatever options you want. So, any questions? I mean, it just depends on the parameters you want. So it's, I mean, as long or as not long as you want to, but um, yeah, I guess just until you get the kind of gears that you want. You can do helical gears too. Those are kind of cool. I just opened one a minute ago. Yeah. So that would be. I don't know if there are worm drives in here specifically, but I feel like they would be in gears if there were. Yeah, yeah. So your pitch and your all that stuff should be the same. Especially this first option here is going to be basically the size of the teeth. Um, so if you change the size of your teeth, but you have more or fewer teeth, the gears will still work together. You're gonna have that ratio going on. But yeah, that's important. And then of course the pressure angle and the face width is fairly important. If your face widths aren't the exact same, it'll still technically work, but it won't be, it won't be the ideal scenario. So, any other questions? Okay. Uh-oh. um, all right. So, mhm. Yeah. Yeah, that's going to be pretty cool. So I published the assignment for I think it's week 4. um, next week's uh, part and justification. And so those should be up in Canvas. Your week 3 stuff is due tonight. I forgot to publish that stuff in Canvas, and student brought it to my attention. So thank you for that. But if you weren't seeing it before, it's up now. So go ahead and get that stuff turned in as soon as you can. And then I don't know how many people have actually been able to print anything. I don't think too many have. So if you guys are able to, definitely get in here and start printing stuff. And you don't have to come in when I'm here. You can come in anytime. You're just gonna have to ask somebody else which printer to use and so on and so forth if you haven't already gone over that stuff. So, um, yeah, and start putting your machines together. If you want to do it at home, that's fine. If you want to do it here, that's fine too. Um, but keep in mind that we're almost halfway through the quarter already, believe it or not. So, so you're going to want to kind of have something coming together fairly soon. So, and I know, I know this quarter is tricky too. The thing with these machines is like, uh, Jason had everybody do these one quarter a while ago, but that was back when, everybody could come in the lab and just print stuff whenever they wanted, and things were a lot easier. So I know it's tricky right now, like actually getting on campus and spending a lot of time here, especially around other people and stuff. So I'm obviously very aware of that and sympathetic to that. So if you have a hard time getting everything printed, that's fine. I just want to make sure that you're all turning in your parts and everything. So at least, at the end of the quarter, worst case scenario, I still kind of want to see everybody mock things up in SolidWorks, like just kind of doing assembly with all your parts. And even if you can't do the whole thing or make it work, just so we can kind of see what you're thinking with it. Um, so keep that in mind too. But the sooner you can get in and print stuff, the better. Um, so cool. All right. If you want to send me any photos of them, that'd be awesome too, because I like seeing what you're all up to. Even if you come in and print stuff and I'm not here, if you want to, let me know how it turned out. Let me know if it was a success or not, and send photos if you feel like it. Awesome. Cool. All right. Okay. Any other questions? Any concerns? All right. I'm gonna stop recording. Unless anybody has anything they want to go over.